If you are that typical DIY dude hovering just above neutral buoyancy in the automotive home gaming sewer, and you find yourself faced with the prospect of interior fit out of your ute or your van or something, and you feel yourself compelled like a magnet being drawn to a self-tapping screw, or even worse, and it hurts me to say this, a tech screw to do the interior fit out of this or that, go find a mirror, dude, have a good hard look at yourself and say the following words. It doesn't have to be this way. All you need is the high-tech miracle of the Nutsert or the Rivnut. Same difference, dude. It just depends which side of the hill you were born on and which magic fairy in the sky Mommy and Daddy told you was the real one. To my way of thinking, they're the same thing, a rivet nut or a nut insert, and that thing is a thing of beauty and a joy to behold. Now, this is half 13 UNC, which is the biggest one I could find, just to give you a better look, but they do make them quite small. This is M3, which is basically analogous to 832 in the imperial world. So there's a range of sizes and they cover a multitude of sins. What you're really looking at here on your right is a mounting flange, and then the splines you can see mark the bit where the rivet is, and right on the left hand edge, if that's not a contradiction in terms, is the nut that you use for threading things together afterwards. And then all you need is the right tool and the right knowledge to use them in the right situations so that the whole thing just doesn't turn into a big fat hand grenade. So let's talk about that. What I've got here, I reached out to my friends at Vivor and said, hey, I want to do this story on Rivnuts because they're really good. And they said, yeah, we'll send you our kit. And the kit is actually quite comprehensive. It's $68.99. If memory serves, you'll get a 5% discount if you use the code in the description. So there's that. And it contains basically everything you need to get started. On the top bit here are all the different mandrels for all the different threads. Now, me, I'm a simple dude. I try and keep myself at M6, M8, M10 and M12 wherever possible. I'm talking metric course, so everything from M12 by 1.75 down to M6 by 1 in the metric course universe, and that means there's only 4 threads. So when you extend that to your ghetto machine shop, that means you only really need 4 tapping drills, and 2 of them are already in your standard drill index. That would be the 5mm drill for an M6 thread and the 8.5 for M10 by 1.5, so that's lovely. And it just simplifies things because there's very little you can't achieve with M6 to M12 in the home shed. But it's nice to have all the other mandrels as well, just in case. And the kit comes with a whole bunch of matching Rivnuts for all those 13 different thread sizes. The 7 metric sizes from M3 to M12 and the 6 imperial sizes from 832 to half 13. So that's lovely. And the final thing, of course, is the dirty big set of riveting pliers to make the whole thing work. Rivnuts are absolutely ideal when you want to put a thread in a piece of sheet metal and you haven't got enough meat for a tap, or even a self-tapping screw is going to just, strip itself out if you've got to unfit something and refit it afterwards a few times, right? So what you get is durability and greater strength, and they're really simple to use and they're cheap. Like, the Rivnuts themselves are dirt cheap to buy. They're available in 3 different materials: aluminium, zinc plated, low carbon steel, like class 4.6 here in the metric world, and 316 stainless. So my take on this is, if you're fitting something to something made of aluminium, use the aluminium ones. And if you're fitting something to the inside of a van, like a tradie van or a camper van or a, serial killer van, then use the zinc plated ones because they're ideal for that sort of low corrosive environmental use, and the zinc is compatible with the steel, and so that's lovely. And if you're using them for exterior anything, use the stainless, because that'll be the most durable. So instead of using a tech screw or a self-tapper to get the number plate or the lights onto a piece of C-section channel or purlin, whatever, that you've just fabbed your tray up for your ex-government Hilux ute, then why not use a stainless Rivnut, which is going to last until the heat death of the universe and look much more professional, be nicer to use, and you also don't have to reach up behind inside and fiddle with, get Loctite all over your fingers once you're finally there, and fiddle with a little nut and a spring washer and a flat washer and then screw them all in from this side, right? So all you have to do is get whatever, an Allen key or a screwdriver on the outside and nip it up. So makes it much simpler, and they're dead easy to use. So to get the thing together, all you do is you take this collar off the front, and then you decide which mandrel you need for the particular job. Let's say you want to use M6 fastener in this case. So you just whip out the mandrel. Mandrel goes in the unit, collar goes back on top, and then the corresponding little guide plate for the front of the collar just fits in place, and you're off to the races. You'll find yourself your M6, which will be the absolute last one. You find yourself your M6 packet, which comes in 2 plastic bags for added hilarity. You whip out your Rivnut, you open the handles, and all I'm basically looking for at this point is for the handles to be as open as they can be, so that the threaded mandrel is as far out of the Rivnut as possible. And when I see it poking out the other side, I know that the threads are engaged fully with the nut, which gives it the greatest chance of success when I crank on it to mushroom the spline rivet over. Here's a real world example of exactly what I'm talking about. So let's say this is the kind of panel, just looking at it, eyeballing it, it's between 1.6 and 2 millimeters thick, so it's absolutely in the sweet spot for this kind of application. And let's say these 4 holes are just here, and I pulled something off and I want to replace it with something else, and I can't get to the back because it was assembled before the whole thing was welded in place, whatever. Anyway, I'm sort of stuffed in this situation, so what I'm going to do is Rivnut it. And the first place to start is, well, what size drill do I need? How big do these holes need to be? You get your Rivnut, you measure the diameter on the spline section, and then you get your fake eyes and you put them on so you can read the whole bloody thing. Incidentally, don't get the LCD calipers. Get a dial set of calipers or just a traditional cheapo vernier set, because the batteries never go flat and the display never malfunctions, and they're dead easy to read down to about 20 microns. So you never need more than 20 microns in the home ghetto workshop, let me tell you. So when I look at this, this is 8.82, something like that. So I'm going to just drill it at 9 millimeters. That'll give me the sweet spot of clearance. What you want to try and make sure is that the hole that you drill is very close to the diameter of the Rivnut, so that when the rivet mushrooms itself over, it grabs as much meat on the material that you're trying to clamp to as possible. If you drilled this at 10 millimeters, for example, you'd lose a whole bunch of strength in the parent material. Let's not forget that the nut itself, the Rivnut, is going to be stronger in many cases than the parent material, which is going to be the limiting factor on the strength of the job. And one of the ways you can mitigate that is to get the hole as close to the diameter of the Rivnut as possible. So 9 millimeters, that's easy. There's plenty of 9 millimeter options. There's one inside every one of these metric drill indexes. If you're looking for a good set of 0.5 millimeter incremental, goes from 1 to 13 in 0.5 millimeter steps. These are from Renegade Industrial. They're imported by a business called Trade Tools in Queensland. On special, they're like $60 or something, and they're really good drills. They're split point, so they don't wander. You don't necessarily need to centre pop them if you're using a drill press because they're very centralised. They're nice and hard, and they're drilled at 135 degrees at ground, at 135 as opposed to 118, which is a more traditional general purpose angle. But the 135 is better for harder materials, and a lot of materials work harden, and it's kind of debatable, but I find they just go a little bit better even on the cheese of steel, which would be low carbon steel or mild steel, which is kind of this stuff, hot rolled, whatever. So do not pay hundreds of dollars for ghetto machining at home because you can get away for well under 100, get yourself a quality index. I don't have any relationship with Trade Tools. I just buy stuff from them because they're good quality and good value. So credit where it's due. Anyway, that's one option. So that's pretty common, pretty accessible. If you're doing a lot of sheet metal though, you can get yourself these spiral step sort of bits. These are from Alcock. I got them from Hare and Forbes. They're pretty high quality as well, a bit more expensive than the Renegade jobs, equally good. Now, what I would strongly recommend you do if you've got a lot of holes to drill, it's easy to overcook it and punch through into the next one. Low speed on the drill is the best bet. And you can see here how I've coloured that one in from a previous job. That I always colour in the next one up so that when you see the colour meet the work, you know to stop. So I coloured that one in at 16. That means I was drilling a 14mm hole, which sounds like me. That'd be a clearance hole for an M12 bolt, basically. So anyway, they're a great option as well, and they tend not to tear up sheet metal as much. And if it's a small piece that you're drilling, they tend not to rip it out of your hands as much because you're not cutting that much metal. And the big danger, well, not danger, but the big issue with thin stock with a twist drill is that the edge of the drill will bite on the way through and sort of rip the metal up or just drag it out of your hands if it's a small piece and you're only clamping it by hand. So you'd want to be fairly careful about that. Slow speed, gentle pressure, just mechanical sympathy, and she'll be right. So here we go. We're going to ream these holes out to 9mm, then we're going to get the 4 Rivnuts in place. So I'd love to tell you that first spiral auger up was carefully planned to show you what can happen, but nah, it wasn't. It just, stuff happens, you deal with it. There's one other step though, stand by. It's probably better, actually scratch that, it's definitely better if you get some good flush contact between the flange and the sheet metal. So if you've got a burr on the sheet metal and you can access the other side, then I'd strongly suggest you do that. If you can't access the other side, that's kind of okay, but at least clean up this bit so that the flange fits nice and flush. So we'll do that now as well. For that, I'm just going to use these zero clearance countersink bits. They're really clever, and in theory, they shouldn't cut at all. They just have a hole in them, right? They're a piece of high-speed steel with a hole in it, but they just do a brilliant job. They're the best countersinks for deburring that I've ever used. So we'll just get that underway, and we'll pretend that we can't reach the other side of this particular job because it's welded in, but we will definitely clear up this face. And just a few seconds spent clearing that up is just going to get us a much better engagement of that mounting flange down onto the surface, and that'll stop the riv nut from sitting, if it should be sitting like this, it'll stop it just kinking up on a bit of a burr and looking like, I don't know, a carpenter did it. So we've got riv nut number 1 in place. We're just going to install it, right? So that's just a matter of poking it through the hole, and then mechanical sympathy, just have a bit of a feel. When it gets tight, you know you've done enough. Don't break the mandrel. Just relax the tension, unscrew the rivet like that. And there you go. There's not much to look at on the side that you'll be looking at. The real magic happens on the inside, and you can see how the spline bit has just mushroomed itself over, and that's very positively engaged. Incidentally, these ones are zinc plated steel, so there's nothing special about any of these, but they'll be very durable indeed. In fact, I looked at the strength up online of a typical 6mm Rivnut, okay, and 13.7 kilonewtons for pull-out strength, and 13,700 newtons is about 1.4 tons, right? That's really 1.4 tons. That's for the nut. There's nothing, like, see, the Rivnut manufacturer can say that because they can get their nut and they can put it in a lab with some sort of controlled material that's not going to fail first. But in many situations, I'd suggest most situations that we would use Rivnuts in here in the ghetto, I'd suggest that the material is going to fail first, or what it's attached to would fail first, right? And we'll talk about strength in greater detail in just a sec, but 2.5 kilonewtons, so 2,500 newtons, 250 kilograms worth of push-out strength. So they're actually much stronger this way than they are that way, which is kind of what you want in most situations. If this is on the floor, whatever you're mounting, you're not going to have trouble keeping it on the floor generally because gravity, but you are going to have trouble, you're going to have to restrain it this way from pulling out generally in most mounting situations. If it's on a vertical wall and this is more like a bracket and there's 4 of them, then there's going to be tensile forces here and they'll be resolved by compressive forces there, and there'll be a shear component as well because the gravity's also going to be pulling down that way from whatever you mount it. So there's all of those things to consider, and now all we need to do is another 4 of them, and hypothetically we'd be able to mount our little whatever we need to mount there, a bracket or a pump or whatever the hell it is, and it's going to be a really cool durable installation. So if you want to look, did I ream that one out? Here we go. If you want to look at that one, you'll see it. You'll see the magic actually happen here if I hold it for you properly. Never actually done one this way before, but you see it mushroom over like that. There you go. That's exactly what you hope to achieve. You can't see any of that typically when you use them, but all you do then is unscrew your Rivnut, 2 out of 4. Now these things are super quick to install as well. It's not like it's a burden, and you get such a better job than if you're just going to use any of the more butchery type methods, you know what I mean? That's a bit nicer. You can have another look at this one going in if you like. Although I'm pretty sure this is not how you're supposed to do it, but it'll work just fine anyway. Here we go. Another couple of advantages about doing this, even if you can access the back, like for number plates and lights and things of this nature, compared with a self-drilling tech screw or a self-tapper, if you use that to fix anything, there's always the danger that something's going to get hung up on it, or a person doing some sort of service job is going to cut themselves on the sharp point of the self-tapper or the tech screw, right? If you do this, it's a much nicer surface to work around because there's no entrapment sort of danger. You're not going to cut yourself. You're not going to get hung up on anything like that. It's just a much nicer installation. It's pretty aesthetically pleasing on this side as well. And the only thing you've got is maybe, this is M6, so you've got maybe 1.5 millimeters of additional standoff off the plate that you wouldn't have had previously if you just used a nut and bolt. And let's not forget, if you had to unscrew this component to get to the back, to take the pump off or to take the motor off or to adjust the belt tension, and then you had to get another wrench and put it behind here and then tighten whatever down, that's a much greater pain in the ass generally. Okay, so there's your basic, here's a Rivnut. Aren't they awesome? They're really neat, they're super consistent, and I would suggest that you put them in your arsenal. Now, obviously the Vevor kit comes with a tasting pack of all the different inserts from half 13 down to 832, or from M3 to M12, right? You get, in the bigger ones, you get 10 of each, and in the smaller ones, you get 20 of each, and they're all in these little packets. But what you need to do is decide what the job is that you're doing, which side you want, and then go and procure the right inserts for you for that job. So the place I get all of my nuts and bolts and hardware of that nature, including Rivnut type hardware, is from Bolt and Nut Australia, and I don't have a commercial relationship with them either. It's boltandnutaustralia.com.au. You can just look for Rivnuts. They've got their own category, and like in M8 there's like 45 different Rivnut variations, flavors if you like, of M8, and they're roughly split equally between aluminium and zinc plated steel and stainless. And the reason there's so many different ones, and this is really important to know, you can get Rivnuts wrong if you get this particular thing wrong, okay? You've got to make sure that the thickness of the material, like in this case, the thickness of the red bit, is compatible with the actual Rivnut. Because if the material's too thick, it's going to eclipse too much of the spline bit that forms the rivet. And that's not going to give you the mushroom that you need to hold the Rivnut in place. And if you're a complete butcher and you've never done this before and you're using the wrong Rivnut, you're going to lean harder and harder and harder, and eventually you'll either break the pliers or you'll break the mandrel, okay? So when I looked at M8, for example, there's a whole bunch of different thicknesses. There's, okay, so 0.5 of a millimetre is the smallest thickness of parent material with M8, and you've got to choose the right Rivnut. And oddly enough, the maximum thickness is 12.7, which is half an inch in the old money, which is pretty freaking thick. Like if it was aluminium or mild steel, wouldn't you just tap it if it was 12 millimetres thick? Anyway, I would, but maybe you don't have a tap and die, and that might be an easy solution, but that is a damn long Rivnut, okay? Much more conventional to use Rivnuts on thin material that's been stamped or deep drawn like this thing, okay? And that gives you a really good result, and it compromises almost nothing. Now, each one has a range. Like the ranges that I looked at typically for M8, for example, were 3.5 to 6 millimetres. So if you're using a plate type stock, you can get a Rivnut that's compatible with that thickness range. Or if you're using thinner stuff, you can get 0.5 to 3 millimetres. And there's a whole bunch of different thickness variations which relate to the length of the spline and exactly where it is. And you need to make sure that your Rivnut is compatible with the thickness of your parent material, otherwise this will go horribly wrong. Okay, so I suppose I should prove to you that it's not just a scam from that horrible troll from Australia on YouTube. These are just some second-hand M6x1 set screws, okay? Like bolts, but technically set screws. And they just thread in really nicely. That's saliently different than using a self-tapper or a tech screw, especially on something that you might have to take off frequently. And it's really nice not having to have the nut and the spring washer on the back and a wrench held in position, lying on your back, round like that. Only having to work on one side of the fixture is great. They're also ideal if you want to put an inspection cover on something, but they're not a one-size-fits-all. There are some contraindications. And number one is, before you drill into anything on a car, it's always nice to know what's behind, okay? So nice if the drill doesn't plunge down into the fuel tank or across a fuel line or across some vital electrical wires that are doing an important job that you might just be upending. And if you manage to do a double whammy there and puncture a fuel line and cause an electrical spark at the same time, then that's going to be fun, isn't it? So I'd inspect what is behind whatever you intend to put a riv nut in before I actually had a crack with the drill. So that's kind of important. I wouldn't use them, on anything kind of structural, which means I would not drill into a drawbar on a trailer and use a riv nut to mount a gas bottle, or riv nuts to mount a gas bottle, whatever. Anything structural, I'd be leaving that alone. That includes the chassis rails of a body-on-frame vehicle. Because if you're not an engineer and you don't know the data, I'd be staying away from stuff like that. I'd be using it to do brackets on the walls inside a van and things of this nature. And also, instead of just using one half 13 riv nut, which I do struggle with the bigger ones. I think M6, M8, maybe even M4 and M5, much more useful for the DIY sort of home game environment in the automotive space. And instead of using a big fat one like this, I'd suggest it might be better to use 4 or even 6 M6 riv nuts, because you've got the same kind of overall fastener area and, quote unquote, although I hate this term, same sort of strength, but you're applying it, in this case, in 4 places on the underlying substrate of metal that's got to carry the load. And I think in most situations, it's actually this red component that's more likely to fail than the fastener or the riv nut. So spreading the load over multiple points in a particular area on a component such as this, a piece of stamped light gauge material, is probably much better than just using one in a big hole in the centre, because point loads are much more difficult for a material and a component like this to withstand, right? So it might be better if you're fabbing up the brackets to go on the inside of a van, instead of just making them, I don't know, 25 wide and having a row of maybe 3 riv nuts or 2 riv nuts, whatever, then why not make them 50 wide and put 4 as close to the extremities as possible, and that way you're just spreading the same load over 4 points widely spaced on a component like this, which is sort of stacking the deck for success, if you like. Import tools can be obviously a bit all over the shop on quality, but this kit from Vevor seems to be remarkably high quality for the price. Like under $70, you get all of the mandrels for all of the threads that you would commonly encounter in your home gaming environment, both imperial and metric. So that is a real plus, and that increases your flexibility into the future. There's a small sample of each of these different threads that you could play around with, but obviously what you need to do then is rationalise that down to the threads, the materials, and the thickness of underlying substrate that you're going to be fitting the nutserts to, and just get more of those ones, you know. The riveter itself seems remarkably high quality, and let's not forget, if it's designed for half 13 or M12 by 1.75, then when you're just applying it to M6 or M8 or even M10, that's a walk in the park for a tool like this. So that's kind of reassuring as well. The handles are nice and rigid. They don't flex when you use the tool. And the main thing for me is that the hardened bits, like this collar here, and also the mandrel itself, when you feel the bits, you can just tell that they're high quality, heat treated, high carbon steel. So they're likely to be quite tough and durable, which is exactly what you want in that home workshop environment. So I guess you could buy a really high quality nutsert tool. If you were putting in 1,000 of these a week, then that would be worthwhile. But can you really justify the price for the amount of time you're actually going to be doing it? If you're only going to outfit one trailer or one van, are you going to spend $500 on the riveter, or would you rather spend $70 on the riveter and spend the $430 you save on something that's just more useful for the van? I know which way I would go, and I understand why the professionals buy really expensive, really high quality tools. It's because they flog them and they have to have them in their hands every day. But certainly the law of diminishing returns is in play, and this kit seems like great value if you just want to get started and have a feel for the whole Nutsert adventure. Anyway, link in the description, 5% off if you use the link or the code, and my work here is done. Have fun nutserting, dude.